Hi, my name is Holger Angenent, and I work at the Computing Center of the University of Münster. And together with my colleague Andreas Wöllmer, who is also present here, and a third colleague, we are running the service Skibo, a file sync and share service for whole North Rhine-Westphalia in Germany, where we have at the moment about 60,000 registered users. Today I only want to focus on databases and on the performance of databases. The thing is, how do you get the fastest possible database? Of course, you put in more and more nodes. Would be one simple question. In fact, the question I want to ask today is rather trivial. So what is an ideal number of nodes to put in your database cluster? Reading is, of course, speeded up horizontally more or less with more database nodes. But what about writing? I asked myself what would happen if I have more and more nodes? Or on the other hand, just a single database node. What would be the difference in writing data to your database cluster? And I did two things to investigate this. On the one hand, I used a simple test setup with 7 machines to simulate uploads to an own cloud. On the other hand, I had to look at Skibo with some real world data and to figure out what are the drawbacks of more or less database nodes. The reason why a large number is bad for writes is, of course, the replication. When you write some data to one of your nodes, the replication has to synchronize this node with all the other ones. And so the more nodes you have, the more traffic this replication will cause. My test setup for this experimental cluster was this 7-node machine. It was an old-fashioned HPC systems, about 10 years old, I think. And I installed an own cloud to the head node with Apache on a CentOS 6 machine with PHP 7 to get it as fast as possible with these machines at least. And on the other 6 nodes, there was MySQL 5.5 running. No, it was MariaDB, but I think it does not make a difference in this version, with a Galera replication. And those nodes had local HDDs and 2 different networks, InfiniBand in the DDR fashion and a 1 gigabit Ethernet. And the software I used was the most recent own cloud version. So then I used Smashbox in a slightly modified way to upload data. There was a test called TestStorm, I think, and I only used the upload part of it to generate as much load as I could to my servers. I uploaded 32,000 files to my server and measured the time. And then I write the number of nodes that I put in my database cluster. And in the second test, I did the same with the other network. There was no other load on the databases, so I only measured the time for this simple test here. And you see here at the bottom a diagram. On the x-axis is the number of nodes active in the database cluster. It goes from 1 to 6, if you cannot read it in the back. And here is the time ranging from 500 seconds to 900 seconds here at the top. And you see that a little bit in contrast to my expectations, the single node database cluster is not the fastest one, but in fact it turns to scale to faster results. Here we have 550 seconds for the 3-node cluster, and then it gets eventually slower for even more nodes. The thing is, this seems to be not a pure write to your database, but there was obviously some reading involved. And this reading got sped up when you have more database nodes. And this almost a factor of 2, let's say, that is speed up, so quite a bit. So I think this is good news. So you do not have to make your database cluster really, really small to make your writes fast. And as I said, for reading, you either want to have a larger database cluster. For the network question, it turned out that there was no difference for InfiniBand or Ethernet. So replication does not seem to be so demanding that there is a difference in at least the sheer bandwidth of the network. I do not know if there is a big difference in IP over InfiniBand or Ethernet that comes into play here. In my next experiment, I had a look at another mechanism of database replication called flow control. This has the purpose that, imagine you have the setup. The replication between your nodes is slowed down if one of your nodes is not capable of writing all the data sets that are written to them from the other nodes. So I used here an Apache server, and I wrote my metadata via a MaxScale database load balancer into my cluster, and to be precise, into one of the nodes. This is my master node here, and these are serving as slaves. And when you put huge load on your slaves, they got two queries at the same time, possibly. One from your MaxScale process to give him data, and the other query might be that there is some replication load from your master node to write data to this node. And when he's too busy with reading, then the writing is slowed down via this flow control mechanism. And I saw in our production system that there are times when flow control is triggered and the whole cluster, in this case, slows down, what you do not want to see. So question would be, can I trigger flow control via putting too much load on a node? And what I did is put some artificial nonsense load on one of the machines, in fact here the second one, so on only one machine. I put in a loop a select query which is reading from OC file cache with some random strings so that these queries cannot be cached. And then I write the number of processes that are putting these reads on my database. The number of nodes here was always 3, so I did not make this variation again because 3 was the fastest version in my last experiment. The number here are, I think this is 530 seconds, so it is similar fast to no load at all. And here is the number of processes I triggered on this database node. The interesting thing is here are 8 processes running on this 8-core machine. So already at this point, the node was fully loaded. There was no CPU idle left. But only when I put there 24 processes to put them under heavy load, then my upload processes then was slowing down. I would have expected to be this really much earlier. But it seems to me that these pure select queries here are not that expensive at all. So maybe they aren't the reason why I saw flow control in our production environment. My next hint would be that I had a look at shares, because those might be more expensive if there were a long change of, or at least a huge number of shares. When I had this data set running here, I had a look at this database node on the command line with the show status, and there you see all this replication measurement values, and here you see flow control paused. This is a fraction. This value is always between 0 and 1. And when it is 0, everything is fine. Flow control is not triggered. When this reaches 1, your database stops working. And here I got 0.02. So that is finite, but not that much. But at least you see flow control will be triggered with this workload on your reading nodes. So my message from this here would be, put in more reading nodes and you can speed up writing, in a sense. Another mechanism to trigger flow control might be to lock a table so that there cannot be any more writes. So with MySQL you can just put there the command log table read and then OC file cache. And when you do this, flow control is triggered instantly and continuously rising until it reaches 1. So locking a table really means flow control is triggered. We keep this in mind for the next slides. So after only using this artificial workload, I had a look at our real-world data from Skibo. Here you see some performance data from 4 database nodes. some of you might know that Skibo is separated into different instances. We hosting it at 3 different data centers. This is the biggest one. And here you see the data of about 9,000 active users. Database server 1 is used here again as the server we put the writes to, and from 2 to 4 we read the data. And you see that there is almost no load at machine number 1. So I think it would be a rather good idea to put in more database nodes here. So most probably the whole thing would even speed up even more. Flow control is not used very much. Here it is, there are 3 zeros behind the comma. But this has one reason. There is a parameter called flow control limit, and I set this to 500. This means only when there are 500 queries in the buffer that could not be written to your database set, only then flow control is triggered. And you see here the maximum value of local queries that have been queued up. And this is more than 1,000. This causes me a little headache. So this seems that our database nodes, and in principle, in general, I allowed them to do so, that are running a little bit out of sync. But when I do not set this value that high, I think the default is 10 or something, then flow control was in some cases triggered quite often, and the user saw rather bad performance with little bit stalling while uploading data, which was the original reason for me to have a look at all this data here. So it seems to me that there is some log-like behavior in different database actions that are used in OwnCloud. As I said, I think sharing might be the cause, but at least these selects I showed on the last slide seem not to be the issue here. Okay, I already said this. No, here, another message I have, at least for myself. When you already have split up your users to different instances, we have a separate database instance for all the universities we are serving, then it could be a good idea to put them into different MySQL processes, because when flow control is triggered, it will not trigger the whole database, but only the university itself. This we saw on different occasions when we had some trouble. When a single user, at least, might cause some trouble due to some crude actions, then he might be able to slow down the whole cluster. But when you have split up this into different MySQL processes, a user cannot affect every other user. The other question I asked myself is, okay, I had the message, put in more database nodes in your cluster, but okay, your money is limited. Where should you save the money? Maybe you can make your nodes a little bit smaller. I had a look at the amount of metadata. We have 76 gigabytes in this instance, where 9 gigabytes are just junk from the activity log, which can be optimized away. Then, yeah, the 256 megabytes we have in this machine are a little bit too much. When we move to smaller machines, maybe we could afford a little bit bigger machines. So to conclude this, I think there is not really a need to make your database cluster small, because you see there is quite a huge amount of read involved in your database. According to MySQL Tuner, we see a fraction of maybe 9:1 reading to writing. And as you see, already a pure write still involves some reading. And to speed this up, I think it's a rather good idea to have big database clusters. But the other thing is I still need to find out what really might cause stalling in the database and this log-like behavior I sometimes see. And I think sharing might be the next thing I want to have a look at. Okay, thank you.
Thank you very much for your talk. Thanks very much. Also excellently on time, so we've got room for questions. And not only that, those people who go over time with their questions are eating into their own break, because there's a break until about 14:30 after this. So any questions for Holger? I'll allow it. David Jericho. You're eating into your own time here. Actually, honestly, I do have one. I know it's knowing that you guys run a physically and geographically distributed cluster, are these database nodes distributed geographically as well?
No.
So you've got a single physical location where all the databases sit, and then it's just the user serving.
Now I understand. At every of our 3 sites, there was a database cluster. So we have 12 nodes all in all, 4 at each site.
4 at each, all right.
But they do not speak with each other,
But
only via the web front
Right,
ends.
excellent. All right, so that's not an implication in the scaling mechanism. All right, excellent. All right, would have been fun to see that, but it's not there. All right.
You do this, I think.
We do a bit of that, and well, but then David's hiding, so you missed that one, dumbass. Yes, sir. Can you speak up a little bit?
I think you were on CS3 in 2016, and then you said you had some problems dividing the writes over all the nodes in the Galera cluster. So you pointed out one node to just do the writes, and the other ones for read. Did you solve the problem?
I solved it by using read-write splitting in MaxScale. At the beginning, we did not do this, and we put the writes on all the database nodes that were involved. But this turned out to be a bad idea because there was some deadlocks. When one database is opened to write it, it cannot be read at that time. And when another database node does the same at the same time, then you have a deadlock, and they have to wait for each other. And it turned out to be a quite better idea to put the writes all in one node via MaxScale, and then everything went fine. And as you saw in the result here, there seems to be no bottleneck in writing only to one node, but this one is the node with the lowest amount of load.
That actually sounds very familiar.